Hello everyone and welcome back. Today's lesson is going to be on high-level languages. I'm going to give a quick overview of what they are and the different types of high-level languages that exist. So a high-level language is a major advancement in programming languages. They are much easier to use than machine language or assembly language. And this is because they're designed to use a syntax that is more like the English language. So a couple examples here would be total equals 1 plus 3, or name equals first name. So they're pretty easy to figure out what's going on when you look at the lines of code. You can see that in the first line, 1 is going to be added to 3, and that is going to be saved into the total. So the total is going to equal 4. High-level languages also promote platform independency. So that means programs written in these high-level languages can be used on different types of computers. So you don't have to rewrite the program every time you get to a new type of computer, as you would have to do with machine language and some assembly language. Now, high-level languages may require a compiler. A compiler is a program that will convert the high-level programming code into machine code. A program needs to be compiled before it can be executed and understood by the computer. Because if you recall from previous lessons, all programming code needs to be in machine language format before the computer can understand it. It needs to be in those zeros and ones. A high-level language might also require an interpreter. An interpreter might be used instead of a compiler. So if the language is not using a compiler, it might use an interpreter. Interpreted programs are interpreted line by line as the program is executing. So they're not compiled ahead of time. Interpreted languages can greatly increase platform independency, and that's because the program code is converted into machine code on the machine in which the program is executing. So it's not converted to machine code ahead of time, as would be done when you're compiling a program. When you compile a program, the program is converted into machine code on the developer's computer, because the programmer is the one that compiles the program, and then they ship the program out and you can install it on your computer. Now, high-level languages can be either procedure-oriented or object-oriented. Procedure-oriented language concentrates on the major task that the program needs to perform. So it could be calculating sales tax, totaling an order, inputting customer data, etc. Now, when using procedure-oriented languages, the program needs to be instructed line by line from the start of the task until its completion. So the programmer decides the order in which the computer processes the instructions, or the correct sequence of instructions. So examples of procedure-oriented languages are COBOL, BASIC, and C. Now, object-oriented languages focus on objects that the program can use to accomplish its goal. So it could be an employee time card, a customer, a paycheck. It could be real-world objects, or it could be objects that are made up inside of the computer so that they don't actually exist in the real world, but they can still be defined as objects within the computer. One advantage of object-oriented languages is that objects can be used in more than one program. So this promotes code reuse and saves a lot of time and money for the company or the programmer developing the software. Some examples of object-oriented languages are C#, Java, and C++. And it's important to note that these languages can also be used to create procedure-oriented programs, so they're not restricted to just object-oriented programs.